Hi, my name is Paula Messina, and I'm going to explain to you Chapter 3, Section 3 of your Larson Calculus textbook. In Chapter 3.3, we're going to be talking about three topics: change of base, properties of logarithms, and simplifying logarithmic expressions. Starting off with change of base, the main purpose of using this method is because, as you may have noticed, your calculator only has two logarithm keys: common logarithm, base 10, and natural logarithm, base e. So for this reason, we use the change of base formula to evaluate logarithm with other bases. The change of base formulas are base b, base 10, and base e. Base b is logarithm base a of x equals to logarithm base b of x over logarithm base b of a. Base 10 is logarithm base a of x equals to logarithm base 10, also known as common logarithm, of x over common logarithm of a. Finally, there's base e, where logarithm base a of x equals to natural logarithm of x over natural logarithm of a. An example of a change of base formula using a common logarithm would be logarithm base 4 of 25, which would turn into logarithm 25 over logarithm 4 when using the base b formula, and after placing it in the calculator it would give you 1.3979 over 0.60206, which simplified is 2.3219. An alternative would be using the same problem logarithm, base 4 of 25, but placing it in the base e formula, which would follow the same steps except with using natural logarithm instead of logarithm when placing it in the calculator, and always simplifying the fraction at the end. Next, we have properties of logarithm. This topic can be connected with previous knowledge about exponential functions, since they are inverse functions. In exponential functions, the exponential property a to the 0 equals 1 has the corresponding logarithmic property of logarithm base a of 1 equals 0. This brings us to the properties of logarithms. There are three properties: product property, quotient property, and power property. This can both be used with natural and base a logarithms. The property of logarithms are useful for rewriting logarithmic expressions in forms that simplify the operations of algebra. This is true because these properties convert complicated product, quotient, and exponential forms into simpler sums, difference, and products. And remember to always be careful when using general properties. As you can see here, it says, there is no general property that can be used to rewrite log base a of parentheses u plus minus v, specifically logarithm base a of parentheses u plus v is not equal to logarithm base a u plus logarithm a of v. So always be careful to avoid these confusions. A simple example would be natural logarithm of 28, where you separate the 28 into 14 times 2 and then rewrite it as the product property as natural logarithm of 14 plus natural logarithm of 2. A more elaborate example would be logarithm base 5 of cubic root of 5, where first you have to rewrite the cubic root as a fraction, then bring the exponent down. Rewrite the logarithm base 5 of 5 as 1, and then simplify. Rewriting logarithms are commonly used to condense or expand logarithm expressions by using a combination of different properties. In this example, we can see the expansion of a logarithmic equation. First, we do power property, then quotient property, and lastly, power property. In this second example, we can see the condensing of a logarithmic equation, where first using power property, then quotient property, and lastly power property. That's all for today. Thank you for watching.